Second derivative test. If the second derivative is positive, then it's concave up. When you are concave up, your tangent lines are always underneath your curve. Also, if your second derivative is negative, then you are concave down. In those situations, your tangent line to your curve is always above your curve. When it switches from concave up to concave down, we call that a point of inflection. Your point of inflection will occur when your second derivative is 0 or undefined. Here are 3 examples of a point of inflection where your graph is switching concavity. So to find your extrema, inflection points in concavity structure, you need to first of all start off by taking your derivative. So we'll take our function, we'll take our derivative, set our derivative equal to 0 and solve it. So we'll pull out our common factor. Then we get critical points from 2 things multiplied together to give you 0, of 0, and of 3. We'll put those on a number line. And then we once again want to check points in between each of these into our derivative to see where we'll have a max or a min because we're looking for the extrema. So you try a negative. Put a negative here, it's positive. A negative here, it's negative. So when you multiply, you get a negative answer, which means you're going down. Try a number in between. Say 1. 1 here is positive. Put a 1 here, it's negative. So it's negative, so it's going down again. Try something to the right of 3, say 4. 4 squared is positive. 4 here is positive. A positive times a positive is positive. So that means you're going up. So that means at this point you have a bottom of a valley, so you're going up. Or I mean it's a minimum. The x-coordinate of your minimum is 3. To figure out the y-coordinate, you take your 3, plug it into your original graph, or function, because we're looking for a point on your graph, and we get negative 27. Now here you're going down, leveling out and going down. That ends up being an inflection point. So you have a 0 for your x, plug in 0 to your original, and you get 0. Your maximums will occur at the top of the mountains. Here we have a bottom of a valley, so therefore it's a minimum. And when it continues down, levels out, and continues down, or would continue up, level out, and continue up, that would be a point of inflection. This point of inflection should also show up when we do our second derivative test. So you do your second derivative, which is just the derivative of what we had over here for your first derivative. Set it equal to 0. Pull out that common factor. 2 things multiplied together to give you 0. Your critical points are once again where your second derivative or first derivative is 0 or undefined. So we want to take these critical points, put them on our number line. Make sure you're labeling your number line appropriately since we're dealing with our second derivative. Label it as f double prime of f. Check a number in each region here. We'll try a -1 into here. A negative times a negative is a positive. So we get our happy face. Try a number in between, say 1. It'd be a positive here times a negative, so it'd be a negative. So then we end up with a sad face, meaning it's concave down there. Try a number over here to the right, say 3. 3 here, 3 here, they're both positive, so we get a positive answer. So we're back to a happy face, meaning concave up. So it switches concavity at 0 from concave up to concave down, so it's a point of inflection, and we already knew that from what we were looking at over here. But your inflection points will always show up in your second derivative test. Only sometimes will they show up in your first derivative test. So then we need to go ahead and find our next point of inflection. We're switching concavity here. Our x-coordinate is 2. You want to go ahead and take 2 and plug it into your original function up here. And then you end up getting a negative 16. So those are our points of inflection. They also wanted to know our concavity structure. Your concavity structure is where it's concave down. Well, that would be from 0 to 2. And concave up from negative infinity to 0. And from 0 or 2 to positive infinity. And here we need to pretty much do the same thing. But we want to sketch our graph at the end. So we're going to start off by finding your zeros. Pull out your common factor. Two things multiply together to give you 0, so you get 0. And then you're going to get examples or roots from this using your quadratic formula, which I then also have the decimal approximations. Your extrema, once again, you want to do your first derivative, so take your first derivative, set it equal to 0, factor it, solve it, you get your critical points. Put those critical points on your number line. Check numbers in each region to see if you're going up or down, plugging it into your second derivative. It'll be easiest to plug it into the factored form. Plug something in between here, negative a half. Plug something in over here. Plug something in over here into that factored form. So that means we have a bottom of a valley, so we have a minimum. Top of a mountain, so it's a maximum. Going down, leveling out, going down, so it's an inflection point. Then you'd actually want to go ahead and find those points. So you'd actually want to go ahead and take and plug negative 1 into your original problem. Then we want to take 3 over 2, plug it into your original problem. Our inflection point, to find that, you want to take your 0, plug that into your original problem. Well, you then want to go ahead and look at your concavity. So that would be your second derivative. So we want to take the derivative of our derivative. Set equal to 0. You're going to get 0, and then you're going to get an answer from your quadratic formula. You're going to put those on your number line. And I'm going to just put the decimal approximations on my number line, because that'll help me out here. Try a number over here. Try a number in between. Into your derivative, second derivative. So then we have more points of inflection, because we're changing from concave down to concave up to concave down, and so on. So we have our initial point of inflection that we also showed up in our first derivative. Take your negative 0.70 and plug it in to your original function. Take your 1.70, plug it into your original function. They also wanted your concavity structure. So where is your second derivative negative? From negative infinity. To negative 0.7, and then so on. Where is it positive? From negative 0.7 to 0, and then from 1.07 up to infinity. And then they want you to go ahead and sketch your fairly accurate graph, which we have right here.